Okay, now let us look at this question. It is given that a quadratic function y equals to a bracket x minus h square plus k, where a is greater than 0 and has a negative discriminant. Now, if you look at this blue graph, right? So this blue graph satisfies the conditions given, right? That is, a is greater than 0. Now, if you look at a equals to 0, what does that mean? A greater than 0 means that the graph has a minimum point. Okay, so this blue graph satisfy the condition. And the next thing is the discriminant is negative. Now, discriminant is negative means the b square minus 4ac is less than 0. And this means that the graph has no real roots. So if you look at the blue graph, it is above the x-axis. So it has no real roots. Okay. Next, we look at this. Sketch the possible quadratic graph. So this is the quadratic graph. Okay. This one, the blue color one. Okay, right. Then the next question, given that the quadratic graph is reflected at y equals to b, find the range of b such that the image of the graph has a positive discriminant. Okay, now here I would like to show two things. The first one is line of reflection. Okay, it's reflected at y equals to b, and this y equals to b is an arbitrary line. It is controlled by my this thing. I can drag it and control the position of the line y equals to b. So from here you can see the y equals to b, the value of b is negative, value of b is 0, value of b is half k, and value of b equals to k, and the value of b is more than k. Okay, so let me hide this line first. Okay, right. So we look at another one. The graph is reflected at the line y equals to b. Okay, so this is the line. This green curve is the image of the blue curve. Okay, right. This, how to get this green curve? It is the image when it is reflected about this line y equals to b. Now, so as I move the line b, the image of the blue curve, which is the green curve, also move. Okay, right. Okay, next. Now, what is this line y equals to k? Now, y equals to k is the minimum value of this blue curve. Y equals to k. Y is half k. Right. Now, k is the distance between the minimum point on this blue curve with the x-axis. Half k is the midpoint. Half k is the midpoint between this minimum point and the x-axis. So this is half k. Okay, right. So now we look again. The question is, find the range of b such that the image of the graph has a positive discriminant. Okay, now positive discriminant. Positive discriminant means the quadratic function has two real roots, two real and distinct roots. Now, afterwards, you please pay attention to the green image, right? The green image. As I move the line of reflection, okay, from y equals to 0 to y equals to half k, then to k. Right? Okay. So now I'll show the line of reflection. So this is the line of reflection, and this line of reflection can move about, move up and down, move up and down. Can be anywhere. Can be below the x-axis, can be above the x-axis, can be equal to half k, can be equal to k, can be equal to more than k, right? Then we look at the image. Okay, so when this blue curve is reflected about this line, this red line, the image is this green curve. The image is in this green curve. What is this slider? This is called a slider. 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 Okay, correct. Okay, so this is my slider. As I move the slider, the value of b become more and more positive, or the value of b become more and more negative, right? So now my value of b, that is y equals to b, is less than 0. Okay, so when the value of b is 0, right, so this is the line of reflection, this is the object, the blue line, the blue curve is the object, and the image is the green curve. Now as I increase the value of b, as I increase the value of b, the distance between b and the minimum point here decreases, and this one, the distance here is equal to the distance above. Okay, increase some more. When the value of b is equals to half k, when the value of b is equals to half k, and we see that the blue curve is reflected about this red line, and the image is this green curve. Now what is this green curve now? This green curve touches the line, the x-axis. So when this green curve touches the x-axis, there is only one real root. That is, the discriminant equals to 0. Now as I increase the value of b to more than half k, so when the value of b more than half k, we see that there are 2 points of intersection. It means that this green curve has 2 real roots. 2 real roots, this means that the discriminant is positive. So I increase some more. Okay, yeah, until y equals to k, and still we have 2 real roots. The discriminant is positive. Now as I increase the line, the curve spreads out, and we have 2 points of intersection. When will they have 1 point of intersection? The curve has 1 point of intersection when when the b is half k. When the b is less than half k, this green line no longer touch nor cut the x-axis, so there's no roots, no real roots. So now the question asks, the range of b such that the image of the graph has a positive discriminant. So in order to have a positive discriminant, we must have 2 points of intersection. The green curve must have 2 points of intersection. To have 2 points of intersection, the value of b must be greater than half k. Anywhere greater than half k, we will have 2 points of intersection. So what is the answer? The answer is b must be greater than half k. Okay. b must be greater than half k.